Welcome Learner, Department of Collegiate and Technical Education, has provided us online teaching and learning platform through LMS. Under this program, we take up the course PCB Design and Fabrication Lab for 5th semester Diploma in Electronics and Communication students. Under this Unit 1 PCB Design Flow, Session 6 now, Design for Manufacturability, DFM. Designing the PCB is not important, the PCB should be manufactured. While designing the PCB, we have to follow certain set of rules and certain set of thumb rules and certain set of IPC standards. Otherwise, that PCB will not be manufacturable by the industry. If the PCB designed by us is not manufacturable, that is waste of work. If we design the PCB track for 3 wheels, that PCB is not manufactured by India, that we have to give for outstation. Design for manufacturability continued. Some of the DFM guidelines are, I will give some of the basic thumb rules and what are all the DFM guidelines should be followed while designing your PCB. Give proper spacing between component to component. Give proper spacing between pad to pad, pad to via and pad to track. Track should not fall on mounting holes. That you have to keep it in your mind. There should not be isolated copper. The copper which is not connecting to any ground or power should be removed while generating the Gerber file. Maintain proper separation between two reference plates which are used for layer stack up for designing the microstrip line antenna and strip line antenna. The main purpose of the multi-layer board is to provide the route the high-speed signals and also provide the strip line and microstrip line antenna in your PCB. So separation is one of the important criteria while designing the PCB. You should not provide any separation what the separate on your wish, but depending on the material available in the market, you have to give the separation. Based on that, you have to decide the track width and other things. There will be proper clearance at the edge of the board, that is 2.54 mm for standard board. That is the edge clearance around the PCB. And in that edge clearance, nothing should be come, track should not fall, pad should not fall, mounting holes should not fall, otherwise the PCB will damage. While designing the control impedance board, test coupons should be provided along with the design specifications. For that, extra material should be provided and PCB manufacturing cost become more. Design specification standards continued. IPC stands for interconnecting and packaging electronic circuits. First thing you have to know what is IPC abbreviation. The IPC abbreviation is interconnecting and packaging electronic circuits. Everywhere IPC standards are followed. For testing also IPC standards are there. For designing the PCB, for schematic capture, for assembling, each and everything coming to the electronic design has IPC standard. IPC standards are useful for creating the component and also for designing the PCBs. You should not violate such standards. In India, most of the companies follows the Bell standard. The most commonly used design standards are as follows. 7 DFM issues potentially lurking in your PCB design. 7 PCB issues most of the time or commonly present in your PCB are as follows. When we are discussing acid traps, we are describing acute or odd angles of the copper features on the PCB circuit board which cause acid to pool during the PCB creation process. That is the angle provided in the PCB should not be acute angle. It is very small angle, and if the small angle is provided, their acid will go into fill and it will try to erase full track in that part. That is called as acid trap. This issue occurs before the wash process, where acid traps allow for residual acid to get caught into these areas and not get cleared away. Those acids entered into that area will not be cleaned, or it will not be cleared, and it will remain there only. That will going to cause cutting of the track. As a result, the wanted copper features, the Gerber file included on the board, begin to open or lost the copper connections. Finally, it will lose the copper connection in that area. This is the acid trap. This is the small area. While cleaning the PCB, in this area, that acid will remain. That will make the PCB track to cut here. This should not be allowed. Such kind of connections are not allowed in the PCB. Therefore, you have to take the track like this and connect it straight. 7 DFM issues in the PCB are continued. This is the one more acid trap method. This method is also not followed. The acid will go and sit here, and it will sit here. It will try to cut this track, and here also. This is also not allowed. Avoid acid traps are especially important within the 4 or 5 mill traces on today's design. If you are routing this for 4 to 5 mills, 4 mill is 0.1 mm track, that will entirely cut if the acid go and sit there. Since they are so thin, they can easily become openings created within the wanted copper due to trapped acid. Some software has built-in checks for these. However, if your software does not, you will have to manually evaluate the board for anything that could cause this. That's why the PCB design is critical work, and PCB designer has to take care each and everything. And if such kind of connections are present in your PCB, obviously that PCB will fail. Silver and islands. This is called as silver or islands. Silvers or islands. This is not allowed. When pressing the PCB in multi-layer PCB, the air will be moved in between the 2 layers. When the air will move in between the 2 layers, that will fly off. This portion will fly off somewhere. That's why it makes a short circuit in your PCB. And here also islands. When compressing the PCB at the manufacturing process, when they are compressing it or pressing the board, at that time some air material will pass in between that boards. Those will make these copper pieces to flow somewhere which should not be flowed. Solder bridges forming between pins. This is the solder bridge formed between the pins. This is the capacitor placed between these 2 points. This is connected between these 2 points. Therefore, that solder bridges is appeared here. This is not allowed in your PCB. Mask relief. This is the mask relief is provided, this green area solder mask relief, and this black area is the solder mask, this is the pad area, and relief should be provided around the pad. Solder mask dam between the pads, this is the solder mask dam between the pads, and this is 2 mil, and 2 mil solder mask dam is not allowed. 7 DFM issues continued. Double check your PCB design rules for mask reliefs. Because of that, this solder mask dam we are seeing. A solder mask relief is defined as an area on your board layout that doesn't need a solder mask application. Actually, this area doesn't need a solder mask area. This is most commonly designated as a thin outline surrounding surface mount pads, through-hole pads, test points and vias. Check out the image flow and you will see the solder mask relief highlighted in the green. Solder mask relief is highlighted here in a green color. So heat sink should be provided to the component. This is the component. This red color is the heat sink provided for the component. While this component is operating, this will produce more heat that will spread all over the PCB and damage the other part of the PCB. In order to avoid that, a heat sink is provided here. This heat sink will absorb more and more heat from this component and evaporate it to the environment. Cold solder joints or no solder joints. See here, there is no solder joints. A dummy track is falling here. This is not allowed. This is also not allowed. See, this pad is there, assembly pad is there, and via is present here. This is also not allowed. DFM issues again. Checks for vias within the pads are essential or not. Here, the via on the pad is essential or not. Actually, it is not essential here. If the via is not properly placed, it could allow solder to flow down into the via. While soldering the component, the via will damage, it will come out of the PCB, then the connection will lost. This will result in a cold solder joint or no real solder connection. This is not a real connection. This is the cold solder joint. What percentage of the via is allowed in the pad before plugging the via is an requirement. In a HDI high density interconnect, via on pad is okay. It is essential there. Therefore, we have to calculate what amount of via diameter is allowed. Most software should be capable of checking for these issues. However, if your design does not, you will have to manually check your design to be sure and it is in compliance with your assembly house criteria. Test points are not included is one of the important PCB design issue. By including the test points in your initial design, you are providing a way to audit and success or failure of the board once it has been completed. You can rework on that board by providing the test points. Otherwise, you cannot rework it. You will not correct it again unless and until you provide the test points. DFM checks must include test point to component clearances, pad size under components, and a way to lock these locations once a fixture is built. Test points locations are locked in your PCB, then it will not move while handling other process in your PCB, while designing it, you have to take care. Copper to the board edge. This is the copper area, brown colored, and this is the board edge. Copper to board edge, there should be a clearance. 2.54 mm clearance should be provided. The copper to board edge is the space on the grip the side of the PCB panel used to transport the boards throughout the manufacturing process. The board has to be transported throughout the manufacturing process. The person has to carry that board. While carrying the board, handling the board, there should be a spacing here and should not copper around the PCB. If the proper spacing between the copper to board edge is not set appropriately, true manufacturing issues can be created. Manufacturing issues, definitely it will be created if you are not providing any clearance around the board. If the copper is too close to the edge of the board, shorts can be created between the electrical current is applied to the panel during the etching process, and your entire copper area will be burned due to the short circuit. When etching the PCB, electrical connections are provided. If you are not provided edge clearance around the PCB, if the copper is present around the PCB tracks will burn it out. Now questions now. Questions 1. Minimum edge clearance required in the PCB is 2.5 mm, 1 mm, 5 mm, 3.3 mm. The answer is 2.5 mm. Second question. The standard used for DFM is IPC standard, ISO standard, ISI standard, none of the above. It is well known, it is IPC standard. The green color present around the pad is, in this diagram, the green color. What is this? I have already explained you in my slide. Acid trap, solder relief, mask relief, solder joint, annular ring. The answer is B, mask relief, solder mask relief, this one. You can say mask relief. Fourth one, the red color area shown by the arrow mark is this one. Acid trap, heat sink, solder joint, solder mask. The answer is heat sink. These are all the references taken from the internet and other journals written by the authors David L. Jones, Howard Johnson, Eric Bogatin. High Speed Design Fundamentals by Howard Johnson is available in it is available in Amazon also, and the thermal issues books by the Eric Bogatin also available. You can refer those textbooks. Thank you for watching.